Hello, everyone. I want to thank you all for joining our webinar today. I'm Oliver Wang, Channel Marketing Manager here at Moxa, and I'll be moderating today's session. We are discussing tips for commissioning, deploying, and managing your industrial network. Recently, we've been receiving a lot of feedback that this is a topic of great interest to control engineers, panel shops, and system integrators. We hope that after today's session, you'll feel better equipped to address some of the challenges that you are facing, either yourself or on behalf of your clients. We have about 30 to 40 minutes of material that we've prepared to share with you today. The rest of the time, we'll open it up to your questions. I encourage you to stick around and don't be shy with your questions. A lot of times, that's the most instructive part of the session because this is when you hear what other users like you are going through. You can use the questions pane on your screen, type in your question, and click send. Please feel free to do this at any time during the webinar. So at this point, I'll hand it off to Rich Wood and Ariana Drivdahl. Rich and Ariana are highly experienced product marketing managers here at Moxa. Between the two of them, they have over 30 years of experience working directly with plant engineers on industrial automation projects and deployments, and they have been very close observers of the growing role of Ethernet networking in industrial operations. Rich.
Thanks, Oliver. Yes, it does look like today's a popular topic. So let's see. Here's a brief overview of what we'll cover today. I'll start by reviewing some of the common challenges found in industrial networks, and then we'll jump into some of the tips, tricks, and tools for configuring and commissioning your industrial network. After that, I'll turn things over to Ariana, and she'll get into some of the best practices for managing and troubleshooting to minimize downtime. As Oliver said, we'll leave some time at the end to answer any questions that you might have. To set the stage for today's topic, I wanted to take a minute to review some of the common challenges we face in designing, implementing, and managing an industrial network. In many cases, we have a lot of environmental factors that a home or office network doesn't have to deal with, such as wide operating temperatures, shock, vibration, electromagnetic noise, and other factors. Additionally, these networks have much higher availability requirements. While a 30-second outage of an office environment may go unnoticed, an outage like this could result in a shutdown or even endanger human life in an industrial setting. Along with that, the cost of downtime can run into the millions of dollars an hour, so designing to minimize unplanned outages is critical. Interoperability is another pervasive issue as companies seek to bring separate systems consisting of various industrial protocols, serial technologies, and discrete I/O together into a common network. And finally, we often see that the people who are held accountable for keeping the plant up and running don't have deep IT or networking experience. So with that, we'd like to get an idea of your current experience level so that we can get a sense for who we've got here today. Please select the option here that most closely reflects your current experience level with industrial networks. All right, looks like most of you have filled it out. And we'll give it a couple more seconds. All right. So about as we expected, 55% of you have control system expertise and some industrial network expertise. About 19% of you are new to industrial networks. 12% of you have enterprise network experience and are new to industrial. And about 15% of you are well-versed in industrial networks. Great. Thanks for sharing. Okay, so let's jump into some of the tips, tricks, and tools for network configuration and commissioning. Excuse me. The diagram shown just kind of breaks down some of the typical steps in getting an industrial network operational. We'll discuss some of the things you can do throughout the process to make for a more efficient and successful implementation. One of the first decisions you'll have to make is whether to use managed or unmanaged switches. There's typically a trade-off here between simplicity of plug and play versus the ability to control and monitor the switches. So if you've got a relatively small network, or you're just setting up some point-to-point communication, you probably want to consider unmanaged switches. The nice thing about these is you really just plug them in and power them up, connect your devices, and you're done. But when you get into more complex networks, that's where you really want to look at a managed switch, which actually adds a CPU to the switch that allows you to do things like customize the security, add network redundancy, actually manage the network, and prioritize traffic. The second main decision that you've got is what kind of topology are you going to consider? This is a diagram of a star topology, which is common practice in an enterprise or office situation where you've got some sort of control center and then individual lines going out to all your devices. The advantage of this, the disadvantage of this in an industrial situation is you've got a single point of failure. If that switch at the core there goes down, you lose everything in your network. It also can be costly, as you've got to run wire out to each individual device. So for most industrial networks, you're going to likely to choose a topology that supports some type of redundancy. And this will allow the network to recover and keep operating if you lose a network link or an individual device. So here are 4 of the common topologies worth considering and the pros and cons of each. So the first is a mesh, and this basically means that every network device is connected to at least 2 other devices, so that you've got an individual backup path to each device. It is highly reliable and self-healing, but in many cases it's just too costly because of the amount of wire that you've got to run to connect each device to every other device. Next would be moving into rapid spanning tree or spanning tree protocol. Again, these are open, but depending on the protocol, you can see recovery times around 15 seconds for spanning tree and about 1 second for rapid spanning tree, which is pretty good, but in many cases not good enough in the event that you've got PLCs that could potentially time out. The next protocol is a ring and chain type protocol. There's a lot of different proprietary technologies that utilize this. Typically recovery times are anywhere in the 20 to 50 millisecond range. These are often fast enough that they will recover and in plenty of time for a PLC that's looking for an input or output to not time out. The disadvantage of those is it's typically vendor-specific technology. And the last that I'll mention is HSR or PRP, which actually brings it down to 0 millisecond recovery time. But in one case, you're setting up 2 completely redundant networks, and in the other, you're setting up rings that are that require specialized hardware. Many find that these are prohibitively expensive unless you absolutely need that 0 millisecond recovery time. And so what we most commonly see in industrial topologies is a ring type network because it eliminates that single point of failure and reduces overall cabling costs. Another consideration will be accommodating any industrial protocols that are currently being used. You really have a couple of options here. In one case, you can rebuild redundant networks there where you've got a isolated network for each industrial protocol that you're using, but more commonly people are either using protocol converters to bring all of those to separate networks onto a common Ethernet backplane. And then if you've got multiple industrial protocols running in a factory environment, there are many industrial switches out there that will allow multiple protocols to run on a single network. If you've got that, you probably want to investigate that. So when it comes to configuring switches, we find that there are generally two camps. The first would be, if you're an IT professional and you've invested in the time to learn and the commands and the syntax for command line interface, this is essentially a programming language. Many of the IT professionals find that this is faster and more efficient for them to manage Ethernet devices. But for the majority of you here today, where you either have a controls background or you're just learning industrial networks, a graphical user interface is usually preferable. These have a couple of advantages. First, it allows you to monitor the devices and give you visual confirmation of the settings that you're configuring. It's a menu-based system that's often common to what you've seen with other components that you're used to configuring. And it utilizes a standard web browser interface, so there's no special software or anything that you need to run in order to access and configure the devices. Okay, so now if we're getting beyond configuring just a handful of devices, most people start to look at network management tools. And so these tools vary from vendor to vendor, but typically they're looking at a couple of different areas that we'll talk about today. The first is really configuration, as we started discussing at the installation stage. Monitoring as you're getting up into operation, maintaining your network, and then troubleshooting. And so we'll talk about some of the things that network management tools can do to ease your life. So the first that we'll talk about is mass configuration tools. And what I've got here is just a simple kind of comparison of using a web interface to configure each switch individually versus using a batch configuration tool. So with an interface, you would generally plug into each switch and power it up. You would set the IP address. You would set redundancy configurations and any other configurations that you need to configure. And then you would repeat that times the number of switches that you have. So in this example, if we're configuring 100 switches, you're looking at a little over 2 hours to configure those switches with just a single redundancy configuration. This will actually get longer as you add complexity to those configurations. On the right, we have the bash configuration tool, which basically allows you to automatically set all of the IP addresses on all the devices in the network by doing a broadcast search, and then automatically takes the configuration you set for one switch and propagates that to all the switches in the network. So you can see here we're going from a little over 2 hours to down to about 12 minutes in this example. So this gives you a sense for how much time and effort that a tool like this can save you. Okay, so here's a couple of screenshots that just kind of give you a sense for what these tools look like. In this case here, it scans the network. All your devices are connected. It goes out and finds them. You set an IP address range that you want to use, and it goes out and configures each of those devices for you. Okay, if you're setting up VLANs, same type of thing, where you can identify which VLANs that you want each individual port to have access to, and it goes out and sets that for you automatically. Another easy tool just allows you to take a common configuration and copy that to multiple devices. And then allows you to go back and actually confirm that you've actually accomplished what you set out to do, giving you that visual confirmation that everything's configured the way you intended. So once you've got everything configured, now you're going to move into kind of the testing phase, and it's pretty common that something doesn't work right out of the box. So this is where some of the troubleshooting tools really help. And so what it does is, particularly when you're setting up VLANs, and one of the more common things that we see is that one or more devices are not properly configured with the VLANs that were intended. And so what you can do is pull a device out, look at the VLAN and other settings that are set on that switch, and compare it to other devices in the network to identify which of those devices is not configured properly so that you can make the modifications and get the system up and running quickly. Okay, and then once you're done and everything's working the way you want it, a very important step is to export those configurations. If something were to happen, you know, in many industrial applications, you know, lightning strikes are fairly common in oil and gas and you know, solar and power. You know, things that could potentially erase the configurations that you've got in your switches, or God forbid somebody gets in there and just starts changing things on you. At least you've got backups so that you can go back to a point in time where you know everything's configured the way you want it. So these tools often allow you to do that in more of a bulk way, so that you're not having to go and do that at each individual switch on its own. Okay, so with that, that brings us to our second poll. So what methods are you most comfortable with for configuring network devices? Command line interface, a graphical user interface, mass configuration tools, or a combination of those methods? Why don't you go ahead and just enter your answer here, and we'll share the results in a couple of minutes here. Looks like we're getting pretty close here. All right. Thanks for sharing. So 50% of you prefer a graphical user interface. Looks like it's followed by a combination of those methods. And we got a couple of you that like command line interface. I guess if you spent the time to learn it, you probably want to use it. All right. So with that, I'll turn things over to Ariana, and she will take you through the rest of today's session.
All right, thanks, Rich, and hello, everyone. Appreciate you all joining us today. I'm going to take over from Rich here and talk a little bit about network management and maintenance and some of the best practices that are associated with that. So Rich mentioned, you know, network management and maintenance, NMS, or network management software, as we like to call it, is something that has become really critical as people are kind of developing these ever-expanding networks. You know, back when we used to just install a 1Z or a 2Z in terms of switches, NMS wasn't really that big of a deal. But nowadays, when we see networks of, you know, tens or hundreds of switches, this becomes really critical to not only configure and design your network, but to be able to maintain and troubleshoot it as well. Some of the great things that you'll find in many different types of NMSs are things like auto topology visualization, which you can see here on the screen. That's basically showing you the layout of all the switches that it sees connected to your network. You can do remote device management, which basically allows you to reach out to any of the devices that are on your network and do any kind of configuration or troubleshooting or diagnostics that you would need to on that device. NMSs typically also include things like real-time event management. So if there is something that goes on in your network, they will be able to essentially capture that data. And then finally, comprehensive performance reporting. And again, this is very similar, where the NMS will essentially keep track of everything that goes on in your network, and then it will save that and retain it for you to view at a later point if you need to review that data. You can find most NMSs from many different hardware vendors. There's also some really great third-party ones as well that are available for use with different vendors. So if we take a look at the efficient visual monitoring portion, there can be many different types of visualizations that you see within your NMS. One of them is going to be a VLAN or an IGMP visualization. So you can actually see all the devices that are connected within the VLANs that you've specified during the configuration phase. You can also see things like a virtual device panel. And what this is just a digital representation of everything that is on the front panel of your device. So if you took a look at your NMS and then you walked over to the device itself, that front panel should be identical regardless of which place you look at it. The real-time events are something that is really great when there is anything critical that happens on your network. So most NMS will basically keep track of every event that happens, whether it's just an informational message like a device configuration changing, whether it's something that's kind of a general warning, hey, you want to be aware of it, like something's not reachable via SNMP, or maybe your switch is starting to get overloaded, those types of things, or critical things like a port is down or a device is down. It can alert you to these problems in real time so that you can address them immediately as they take place versus having to wait for somebody to let you know or for potentially even an outage before you realize that there is a situation. Now, after you spend all this time configuring and designing your network, the one thing that a lot of people actually forget to do is back it up. If you spend all this time creating a configuration that works, testing your network, troubleshooting, make sure you back it up, because if something happens and your network goes down, or potentially you have a device that you need to swap out on your network, having this backup of your configuration will save a significant amount of time and effort on the back end should you need to make any kind of changes like that. The nice thing about NMSs is that most of them support what we call one-click, which means that there's just one button that you check and it'll essentially back up your configuration and the firmware that resides on all the different switches. You also have the option to schedule that nightly or daily, or however often you would like. So it'll essentially create that snapshot of all the configurations on your network at any point in time. And then it'll also share with you things like the configuration change history. So if you create a snapshot, or if you save your configuration and then you modify it, NMS can actually show you the difference between the two for easy diagnosis. One of the nice things that you see on a lot of industrial switches that you don't often see on the commercial space is basically an easy backup configurator. So this typically is in the form of a dongle or maybe an SD card, depending on the vendor that you look at. But what it does is it basically stores a configuration on the actual unit. And so if you have a situation where maybe you're the IT professional or you're the network professional and you've done a great job of configuring all the switches, and then it gets handed off to someone who maybe doesn't know as much about networking as you do, a backup configure like this basically makes it easy to restore what you had put on those devices in the first place. So all they need to do is basically plug it in, turn on power, and you can restore the original configuration that you had placed on it before. A lot of people do these if you're talking maybe like in ITS or transportation, roadside cabinets. People will place one of these devices and a dongle into each of those cabinets, and that way, if for some reason that particular switch loses its configuration, you don't need to have anybody with a networking degree or networking know-how go fix it. You can just send any kind of tech out there. They can plug it in, and the switch will be restored very quickly. It's a very handy tool that, again, we don't really find that often in the commercial space, but it's becoming very prevalent in the industrial space. Now, one of the other things that we're starting to see a lot more prevalence of in the industrial space is cybersecurity. And, when you're talking about maintaining a network, that includes things like protecting your network against outside intrusions or attacks. And, this started also in the consumer or the commercial space, but, unfortunately, hackers nowadays have realized that taking out a power plant or a large factory is a very appealing target. And so, we're starting to see the need more and more in the industrial space for, security inside of the networks. There is kind of a two-pronged approach, to making sure that you have a secure network. The first is to put defenses in multiple places. So, you can do things like defending your networks and the infrastructure as well. And essentially, the way that you do this is by encrypting the traffic that goes through your network. And then you also have basically your enclave boundaries, or basically the end devices of your network before it goes out to the outside world, if you will. And these are things like firewalls, intrusion detections, and those are the ones that try to keep those hackers out. Now, once you have both of these in place, you're really kind of layering the defenses. So, you make it difficult for a hacker to get into your network, and then if by chance they happen to get into your network, you also have that additional encryption protection within your network to try to keep them from viewing the data that's going across it. So a layered, solution would look something like this for an automation factories. You have your security site, which is basically an overall hierarchical type of protection. And this is typically a firewall that's going to be installed at the edge point of your network before it goes out to the internet at large. Then beyond that, you can have what we call our security zone. So you can have, all of the devices within a specific type of a network that are going to be included in that security zone. And then finally, for the edge devices, you can have what we call a security cell. And this is, where you can basically segregate different parts of your network into secure areas. Now, to make sure that your devices are as secure as possible, we always recommend ensuring that the firmware is up to date on your devices. Now, firmware updates, can include two things. They can include bug fixes, which can certainly include security fixes or security patches, but it can also include things like additional functionality. So most vendors will have, a couple of different firmware upgrades that they put out a year, and it's really a great way to bring sometimes even legacy or aging switches up to the latest technology. So it's something that we definitely recommend, and ensures that your devices are up onto the latest technology. So we're going to ask you guys for one more poll here, if you don't mind, and that is, what tools do you currently use to monitor your network performance? And we're going to give you just a few minutes here to answer. It looks like by and large that most of you actually don't use any kind of network monitoring tools, which is something that you definitely may want to consider in the future, given the many benefits of being able to use those. So we'll give you guys just a few more seconds here. Looks like we've still got some responses coming in. Give me maybe another 5 or 10 seconds, and then we can close it out. All right, so here are the results. As I mentioned, about 66% of you say that you don't currently use any kind of NMS system. About 12% of you say that you either use an enterprise NMS or a third-party NMS, and followed closely by the last 11% of you, which use industrial NMS that's typically provided by whatever switch vendor you would choose. So thanks, you guys, for participating in that poll. And we're going to go ahead and move on here to how to minimize downtime and network troubleshooting. Now, Rich mentioned very briefly at the beginning of this webinar the differences between unmanaged and managed switches. And while we see a majority of people leaning towards managed switches in industrial networks, a lot of people are still using unmanaged switches. And one of the biggest questions that we get is, how can unmanaged switches be used in the network to, let you know when there's a problem? And, unfortunately, unmanaged switches are very simplistic devices, so they typically can't communicate their status of the network the way that a managed switch can. However, they can be used to, configure the relays that are on most of the industrial switches, and those relays can be triggered, when you have things like a power supply failure or a port break alarm. You can tie those to a PLC or some other device that can actually have the intelligence to send you a snapshot or send you a message across your network. Now, if we're talking about managed switches, there's a whole host of things that you can do to be notified of, a network outage or a problem on your network. And one of the things that is very easy to do is have an event log or an alert. So most devices in the industrial space will allow you to activate specific issues or specific triggers, if you will, on your network to notify you. So these can include things like a cold start or a warm start, whether somebody changed a configuration that they weren't supposed to change, whether you have a power supply that failed or either came back online, and there's a whole laundry list of things that you can do. Now, one of the nice things about industrial NMSs is that some of them even support, basically to-go functionality that you can view on your smartphone. And this is really handy because you don't have to be physically tied to the computer that the NMS is running on to be notified of an alert on your network. It can pop up on your phone. So say you're at lunch, you see an alert pop up, and you go, oh, I got to get back to the office and I got to figure out what's going on with my network. Without that kind of functionality, you would have had to wait till you got back to the office and logged in to see what was going on. Now, having a reactive type of a situation is fine, but even better is being able to predict or have a proactive kind of monitoring. So one of the things that we are starting to see on industrial switches is actually fiber monitoring. Most people don't realize that fiber does degrade over time, not just the glass itself, but the transceiver and the receivers tend to degrade over time as well. And so wouldn't it be great if you were running a fiber network if your devices actually told you, hey, my fiber is starting to degrade, I'm not able to maintain the distance that I was when you first installed me. And that can save a lot of headache and a lot of time down the field when you have an actual outage, because you can preemptively replace the fiber if you have that type of a situation. And if you enable this type of functionality, typically you can see the events come in as either an SNMP trap or a relay or even an email or some sort of an event log as well. Now, one of the other nice features of an NMS system is basically a network snapshot comparison tool. So if when you install your network and you commission your network, everything is up and running properly, it's a great practice to basically take a snapshot or a picture of your network. If at some point down the line your network fails or you begin to have errors in it, what you can do is take an additional picture or an additional snapshot and then have your NMS compare the two, and it will actually show you the physical locations of the devices that have changed since your network was healthy. So here you can see what some of the things you would see is when you actually do the comparisons. Let me back up just one slide here. So you can see that this will actually tell you the IP address, the MAC address, the name of the switch if you've named it, the location to it, and what the change was since your network was healthy. You can even take it one step further and compare two of them side by side, and it'll actually tell you what has changed amongst them. Now, if a snapshot is a picture, event playback is essentially a video. So what event playback does is it basically captures a video of what's happening with your network, and then you have the option to review it at a later point in time. So say when you leave the office for the day, at 5 o'clock your network is running great, you come in the next morning and everything is down, and you look at your network and go, oh my goodness, what in the world happened? So event playback will basically allow you to see what happened. So your network gets played like a video, and that includes things like alerts or event logs all being played essentially in real time, or you have the option to speed it up as well. And it makes it very easy to see what happened on your network, when it happened, and to be able to fix it rather than trying to kind of piecemeal together what happened while you were out. Now, another thing that NMSs can do that's really useful in terms of troubleshooting is quick device finding. So say you have a whole cabinet or a whole panel full of switches and you have one switch that's acting up. On the NMS side, if you're working on that portion of it, it's pretty easy for you to tell what switch is having problems. But if you have to pull the plug from that switch in the cabinet, or you're working with someone who is remote at that cabinet, it's pretty hard to tell them which switch it is if they all look the same. So with quick finding of devices, what happens is you can tell the switch, hey, flash all the lights on the front panel, and that way it's really easy to determine which switch is the one that needs to be changed, or which one needs a cable change, or what have you. All right, so I'm going to do a quick recap here for you guys. I hope that this has been a very insightful webinar for you guys, but just kind of a quick summary. There are, as Rich mentioned, different redundancy protocols that will allow network stability and recovery, and they each have pros and cons, and it's definitely up to each of you guys to figure out which is going to be the right one for your network. An NMS tool is something that we honestly cannot recommend enough. It is just a wonderful, wonderful tool that makes your life so much easier. They do allow everything from quick device configuration and mass deployment to troubleshooting to maintenance to visually seeing the way that your network is and if it's healthy or unhealthy. All these things bring together an overall picture of your network that you really don't get without any kind of an NMS. All right, and with that, I believe we are done with the presentation portion of our webinar. We're going to throw it over to you guys and see if you have any questions that we might be able to answer for you.
All right. Thank you very much, Rich and Ariana. Looks like we already have quite a few great questions coming in, and they keep on coming in, so please continue to submit your questions. Anything that we're not able to get to within our allotted time, we will definitely be sending a follow-up to everyone who's attended here. But let's start with the first question. Is network management software vendor-specific, or are there third-party NMS vendors? Rich?
Sure, yeah. We mentioned earlier that there are some third-party vendors, such as one of the bigger ones is SolarWinds or SNMPC. These are pretty large-scale enterprise network management systems with price tags that go along with it. Then several of the major network component providers, like Moxa, provide a version of network management software as well. The vendor-specific solutions typically will have more capability for their own products, but typically can see third-party devices if you have the MIB files. So, generally, I think most of the customers we work with will start with a vendor-specific network management software, and if they get to a point where they want to integrate it with some of their enterprise or larger scale networks, then maybe they'll consider one of the higher price tag third-party solutions.
Thank you, Richard. Let's go to the next question. You focus a lot on software tools in today's webinar. How much do these cost?
That's an excellent question. Thank you very much. The cost of NMS systems varies. So, some organizations will give it out for free or at least up to a certain port or switch count. There's some that cost a significant amount of money. Some can be thousands of dollars. They really run the gamut. And so, I would definitely encourage you to check with your switch vendor. Typically, industrial ones tend to be a little bit lower cost than the ones that are third-party. However, the third-party ones tend to have a little bit more functionality in terms of integrating other devices than some of the industrial ones do. But either way, I would definitely encourage you to take a look at whoever your switch vendor is and just ping them on what kind of NMS is available for free for you to try out if that's something that you're interested in doing.
Thanks very much, Ariana. It looks like we had some audio issues with Rich's previous answer, so I'm going to go ahead and repeat that question and allow Rich to answer that again. The question was, is network management software vendor-specific, or are there third-party NMS vendors? And thank you, everyone, for providing your feedback and letting us know about those issues.
Okay, sorry about that audio issue. Yeah, so the answer to that question is there are both. There are third-party software vendors. Some of the bigger ones we see out there are SolarWinds, SNMPC. Both of these enterprise systems tend to be, up in the $10,000 range is kind of the starting point. Several of the major switch manufacturers also offer, like Moxa, their own network management software. What we find is that the vendor-specific solutions, while they will tend to have more capabilities built in for their own products, pretty much all of them can see third-party devices as long as you have the MIB files, which pretty much every vendor is going to provide a MIB file for a managed switch. Most of the people we see start with a vendor-specific solution based on the products that they're using. And should their network get to the point where it's just sprawling, they'll potentially consider one of the third-party solutions. I will also, on the other question that was asked, as far as price ranges, typically we see, in the $1,000 range to upwards of $10,000 for a network management software system. But what we do also see is, like with Moxa products, the auto configurator products are typically free, and most of the vendor-specific network management softwares, and even some of the others, will have either trial versions or free versions that have a limited either feature set or a limited number of nodes. So for the Moxa, if you have less than 20 nodes, the network management software is free.
All right, thanks very much, Rich. We have a lot of great questions. Here's one that a couple of attendees have been asking. Is there a network management software that works with third-party managed switches, layer 2 switches? Many of the networks have grown to include many switches, some from Cisco, Stratix, Moxa, and others. Rich, Ariana?
Yeah, sure. I mean, that's pretty much a piggyback on the last question there. And yes, the MIB file is really using SNMP, or Simple Network Management Protocol, is typically what most of the network management software works off of. That's a standard protocol that pretty much all device manufacturers work with. And the MIB file is basically a file that you would get from your switch vendor that would plug into that software and tell it how to read that information. So, so yes, in general, those software programs do work with third-party vendors.
Thanks very much, Rich. Here's another question. They've covered some of the basic tools for troubleshooting networks. Are there any tips for other more advanced diagnostic tools?
Yes. Well, with the topics that we had today and the intended audience, we kind of started with the basics. There are certainly tools, more advanced diagnostic tools out there. I'm just like some of the ones that our support personnel use. One of the more common ones is Wireshark, which is a network protocol analyzer. iPerf and JPerf for traffic generation and system performance. Landbreaker for testing recovery times, and Multicast Hammer for multicast testing are some of the, I guess, top tools that we use. If you do have interest in more in-depth, kind of level 2 troubleshooting networks, please indicate that on the closing survey, and we'll try to put something together on our calendar for future webinars.
All right, thanks, Rich. Another question. They keep on coming. So this is some great questions from our attendees here. Thank you very much for your engagement. Is there a place where we can get information on all switch CLI, that's command line interface options, beyond just the help section?
Yeah, thanks, Caitlin. That's a great question. Yes, we, at least with Moxa, we do include a CLI manual in all of our switches, and that will basically give you, all the details that you need about CLI and how to use it within our own devices. I would imagine that many vendors do the same thing. CLI is one that was started essentially by Cisco, and so a lot of the industrial vendors that support a CLI will have a variant of it that closely resembles what Cisco has. So if you're already familiar with the Cisco CLI, you will basically, in turn will then become very familiar quite easily with some of the industrial CLIs as well. Like I said, if you're starting out fresh and you kind of want to get into CLI and you want to learn, then we definitely would encourage you to check out the manuals. We're also here to help if you ever want to talk to us about it as well. And it looks like there's a follow-up that came through to that one, which is, do all Moxa managed switches support CLI? And the answer to that is yes. All of our switches that are managed do support CLI.
Thank you very much, Ariana. Let's continue with some of the questions. Here's a cybersecurity related question. It looks like a couple of people had this question. Is a managed switch an absolute requirement to provide any level of security against unauthorized access? What is the best firewall for Moxa for securing a controls network from a corporate network?
Okay. For the first question there, I mean, with an unmanaged switch, really the only way to secure the network is to restrict physical access. You know, essentially lock the switch in a box, or there's little third-party devices you can stick into any unused port, which will physically lock it from getting somebody to be able to plug into it. But a lot of our customers are using a combination of unmanaged and managed switches. So on the edge of a network, you may have a manufacturing cell or something that is connected using unmanaged switches, but at some point that cell is connected to the larger network, and that's typically the point where either a managed switch or a firewall type product would be installed to basically protect the rest of the network from anything that could happen in that cell where there's not the level of security that that you want to see. So hopefully that answers your question.
And then the follow-up to that question was, what is the best firewall for Moxa for securing a controls network from a corporate network?
Well, and that really depends on, you know, where you're using it and what you're trying to protect from. You know, I think Ariana talked a little bit about the tiered approach, where, you know, you typically will have a firewall that's, you know, isolating kind of the manufacturing portion of the network from your enterprise network, and typically there'll be some sort of DMZ or demilitarized zone in between. You know, so Moxa makes a product that fits right into that, the EDR G903. You know, certainly we would want to know more about your application before actually making specific recommendations like that. But then down at the cell level, you know, we see that not only do you have to protect against intrusions or, you know, malicious intent, but in many cases, some of the devices themselves, if they're malfunctioning, will create tremendous amounts of broadcast network traffic that you want to protect the network at large from, you know, and isolate that type of traffic to the particular cell where there's a problem. And so some of our combination switch firewall products like the EDR 810 are more appropriate in that type of environment. But I would say definitely get somebody involved, you know, call our support line or get your local distributor or salesperson involved, and they can help you based on your specific application.
Thank you very much, Rich. I think we'll take maybe one more question, and then we'll call it a session here. Last question: is it possible to monitor network devices using my Skata systems?
Sure. Yeah, typically, you know, most of the Skata systems are typically using OPC tags to monitor the devices, and you know, certainly that's something that a lot of the network management software will also take the SNMP data that's coming from the switches and allow you to create tags that allow you to monitor that the network type data on your Skata system.
All right, thank you very much, Rich. Before we close it, I want to thank Rich and Ariana for sharing their time and their tips today for today's session. I'd like to ask everyone here a quick favor. Please complete the survey when the session is ended. It really helps us understand if we're hitting the mark with this kind of content and topic and what we can do better next time. So with that, everyone, thank you very much for attending. We hope you found it very helpful. Please have a great rest of the week.